So let's talk a little bit about DNA, stress, and aging. Have you ever seen a picture of the President of the United States before they go into office and then after? They have so much more gray and white hair after they have left office, whether it's for 1 term in 4 years or whether it's for 2 terms in 8 years. If you haven't noticed this yourself yet, go back and look at some of the images. It is pretty amazing. And you'll notice that there is so much more gray and white than you would assume to see for just a 4-year period or just an 8-year period. And that is because one of the things involved in the office of presidency should be the experience of stress. This is the American people really count on someone being in a position where they're struggling with really important decisions to make moment to moment. And when that happens, again, cortisol enters their body just like ours. And something that cortisol does is it is actually directly connected to aging of specifically of the cells in our body, so at a very molecular level. And how it does this is cortisol is actually a bit of a solvent. So it breaks down what is in its environment a little bit. So here, if we look at a DNA molecule here, right? So you have the helix going around, and you can think about this as like a rope, right? And there is a lot of little pieces of information all wrapped up inside of that rope. And it is really important that the rope stays tight and organized. So there is a very specific strand of amino acids whose job it is to keep the rope tight. I mean, it's the same job as, when you take a lighter and heat up the end of a piece of rope after you've cut it so it doesn't fray out at the end. Same concept, right? These guys here are called telomeres, and they're very small, but they have a really important job. So what they do is they hold all that tight, just like that piece of rope, and they stay all of this data that is in the DNA molecule in a really organized way. Because again, there's a lot of information here. In this DNA, part of its job is to keep us who we are. See, the cells in our body, they don't get to have sex like animals and humans. They don't, especially humans, they don't get to have fun, right? What they do is they just kind of asexually bud, what it's called. So all of these guys, these DNA strands, line up in the middle, and over time, they work together and they replicate themselves and they pop right off. And in doing so, it is really important that this DNA can replicate itself just so. If it cannot, you're going to imagine what happens to all that really, really dynamic information that has to stay organized in order to replicate itself in that dynamic fashion. It gets frayed. It gets disorganized. And this is literally a really important component of aging. The thinner these telomeres get, the more they're exposed to cortisol and the solvent properties of cortisol, the less they can hold these strands, and the more that the cells in our bodies are actually at risk of genetic mutation and aging and falling apart. And eventually, when the telomeres are done, they have a finite age. They wither up. They pass away in a much similar way that human beings do and other animals do. So before you go out there and decide to get really stressed out with the next thing, moment to moment in your life, just give a moment and think about how much cortisol you want flowing around in your bloodstream today.